In this video, we're going to take a different perspective on the multiplication that we did in the last video, the multiplication of two matrices. And I think this is a kind of a more powerful view of it that will allow us to understand things later in the course a whole lot better. And so you may have noticed when we took m times x and m times y, especially when we took m times y, that the second column of the product was identical to the fourth column of the original. Okay, and there was definitely something there. Maybe even notice it when we were like doing the sevens and doing the multiplication, what some might describe as the rote way. Okay, but I think it's actually going to be easier for me to show you what's going on to talk about m times x. So what we're talking about here is combinations of the columns when we're multiplying a matrix times a vector on the right. And so what I'm going to do is just say, okay, this 21, 20, and 26, I'm going to show you how we can cook this up out of combinations of the columns of m. Okay, so that 1, 2, 3, 0, negative 1, 0, 4, 0, 1, and 8, 9, 11. Okay, when we multiply m times x, which is m times 1, 0, 1, 2, what we're doing is we're combining 1 of the first column plus 0 of the second column plus 1 of the third column, plus 2 of the fourth column. And if you think about adding all that up, just like look at the first component. 1 plus 4 is 5, plus 16, that's 21. If you do it with the other components, you'll see that this is equal to 21, 20, and 26. So we've got something going on here. With that in mind, I think it makes it really easy to understand what's going on with the red, why we're just copying out that fourth column looking at the second column of y. Just kind of isolating the problem here. If I was to take m and multiply it by the second column of y, m times 0, 0, 0, 1, and look at it from the same combination of the columns perspective, I'd be taking none of the first, none of the second, none of the third, plus 1 of the fourth. And that is going to be, exactly why I get, a result of 8, 9, and 11. So I could finish that off and say 8, 9, 11 right there. Okay, but that's what we've got going on. That's really what I wanted to show you here. Okay, so that brings us to our new formal definition of matrix multiplication, which is if A can be written as, these columns, A1 through AN, and that does mean that A is going to be an m by n matrix because it's got m rows. We don't know how many rows it is, doesn't really matter. And it's going to have n columns. That does matter because that's what we're talking about here. And then we're going to be multiplying it by a vector x, which must have n components in order for the multiplication to be defined. And we're going to get A times x. Our formula is going to be, that components of x are how many of each of the columns we use. So it's x1 of the first column, x1a1, plus x2a2, plus, we're doing all of the rest of these combinations up to xn of an. That's our definition. Okay, so for example, I've got, we can do here. We don't need to do a whole lot of them. If you want more practice, go look at the homework. But, we've got this matrix B, and I've got X, Y, and Z. And I think that this is a good set of 3. So for BX, we're thinking B times 1, 1, 1. So that's going to be 1 of the first column plus 1 of the second column plus 1 of the third column. We're going to add the 3 columns together. Add all 3 columns. And so when we do that, thinking about the first component, kind of adding across the top row, I'd have 0 plus 2 is 2, then 4, and then 4. Okay, so BX is 2, 4, 4, because I added the 3 columns together. If I wanted to think about BY, okay, that's going to be 0 of the first, 1 of the second, none of the third. Okay, so we're just going to copy the second column. Okay, so copy the middle column, and then that'll be BY equals negative 1, 0, negative 1. Oh, goodness. And for BZ, okay, 1 minus 1, 0. So 1 of the first column minus the second column, 0 of the third column. Ignore the third column. So that's going to be basically take column 1 and subtract column 2. So I'll just call that column 1 minus column 2. And 1 minus negative 1, 1 minus 0, and 1 minus negative 1 would be, I think, 2, 1, 2. Yeah. And that's really what I think I wanted to show you here in this video. You know, this is going to be a better and more intuitive idea of matrix multiplication, but I think it's also more powerful after you've done a few the old-fashioned way. So that's why I waited until after I'd shown you the old way to show you this one. So that's going to be all for this video. Thanks for watching.